This is the solution to problem number 7 from the fall 2017 exam. A child throws a snowball from on top of a treehouse at an unknown angle. The treehouse is 4 meters off of the ground. The ball lands 10 meters away from its starting point 1.2 seconds later. So we know that it's airborne for 1.2 seconds. The formula that we're going to use is that the position is equal to the initial position plus the initial velocity times time plus 1/2 times the acceleration times time squared. The way to think about this problem is in terms of components. We know that it traveled 10 meters in 1.2 seconds, so we know the x component of the velocity. If we write it out using this equation, 10 meters equals 0, it starts at position 0, plus the initial velocity times time, plus 1/2 at squared, and this term is 0 because there's no component of acceleration in this direction. And so we know that it covers 10 meters in 1.2 seconds, and therefore the constant velocity in the x direction is 8.33 meters per second. In the y direction, we know that it ends at 0 meters, but it started at positive 4 meters in height, plus the initial velocity in the y direction times time, minus 1/2 times gravitational acceleration times t squared. If we plug in the numbers, we know that it was airborne for 1.2 seconds. We plug in those numbers and we solve for v0y, and we get that v0y had to have been 2.55 meters per second. Now, at this point, we know the initial x component of the velocity is 8.33 meters, and the y component of the velocity is 2.55 meters. If we write it out in terms of the initial velocity, there's some unknown initial velocity v0 times the sine of that initial velocity, of the angle rather, equals 2.55, and the initial velocity times cosine of the same angle, theta, equals 8.33, so that we get the x component is 8.33 and the y component is 2.55. We can take the ratio of these, and if we do v0 sine theta over v0 cosine theta, the v0's cancel out and we get tan theta, and this is just 2.55 over 8.33. So we have tangent of theta equals 2.55 over 8.33, and that gives us a theta of 17 degrees. Another way of thinking about this last step of the problem is we could draw a vector like so, and then we have that the x component of the vector is 8.33, the y component of the vector is 2.55, and we're asking what's the angle. Well, tan of 2.55 over 8.33, or tan of theta equals 2.55 over 8.33, and that gives us our solution. So that's another way of thinking about it trigonometrically. And that's the solution. Theta equals 17 degrees.